Okay, good morning, Professor. My name is Tang Hui Ming, and this is my presentation for the second project of this class, which is to write a quicksort algorithm in SML. So here is my function, quicksort. It has two base cases, one for an empty list, another one for a list of only one element. And the important case, the one where it sorts the list. When the list is there's multiple elements in the list that needs to be sorted. It works for integers. I'm not sure if it works for float or not. I've only tested it for integers. So in this function, I define two other functions, helper functions, one called partition and another called combine. I'll explain the easy one first. Combine is used to combine the left array with the pivot and the right array. If you don't know what the pivot is a special variable used to partition a list in a quicksort algorithm. And that's where my partition algorithm comes in. It also has two base cases, one for an empty list and another one for a list of one element. For the case where there's a list of one element, it will check if that element is less than the pivot. Then it will put that element in the left or right sublist. So this function partition returns a tuple of two lists. So I have a little drawing that explains a bit more about how partition works. So given an array 1, 2, 3, and 4 and the pivot 0, it goes through the array elements until it reaches the last element. Then it calls partition on the last element, which is still a list. It checks whether the last element, in this case 4, if it's less than the pivot. If it is not less than the pivot, then it is put on the left, but in this case the pivot is 0, so it's put on the right. Same goes for 3, 2, and 1. So that's how partition works. Okay, now that I've explained the two local functions that I've defined, now I'm going to explain how quicksort works. So quicksort first calls partition on res. Res is the tail of the list, like the list that's passed to quicksort. Pivot is the head, and res is the tail. So partition is called on res, and it will keep partitioning the list until there's no more element. Of course, I have a tuple here with left and right to hold the return value or returned list. And then in the expression that needs to be evaluated, I call combine, and I recursively call sort. So here is a drawing to explain what the quicksort algorithm does. So the first call to quicksort, let's say given a list 3, 1, 4, 6, the first call to quicksort will call partition with res. So res in this case is 1, 4, and 6. Partition will return a tuple of two lists. One being the element is on the left, is in the left sublist because 1 is less than 3. 4 and 6 is in the right sublist because they are greater than 3. Then it calls quicksort on 1 and quicksort on 4 and 6. You can see here, QS is a short for quicksort. And as you can see, calling quicksort on 1, we call partition on an empty array and we get two empty array. Therefore, we are trying to combine two empty array with the pivot 1. As for calling quicksort on the 4, 6 array here or list, I come from C++ background, I call them array, but essentially they are the same in this case. So quicksort will call partition on 6. 6 is res, 4 is pivot. And here we go. 6 is greater than 4, so it's put on the right sublist. And then it calls combine with an empty left sublist, the pivot 4, and the right sublist, which is 6. So combining them all together here, even these empty lists, will produce a sorted array. I'm going to circle all the combination here, the elements that needs to be combined. So if we combine empty with 1 and empty, then combine with 3, with another empty, with 4, with 6. So let me demonstrate the program. Let's see. Let's call quicksort on a list of 5 elements: 8, 3, 4, 2, and 0. So the result should be 0, 2, 3, 4, and 8. I forgot the semicolon. 0, 2, 3, 4, and 8. Boom. Let's try a bigger, 10 elements. So 1, 2, 3, 4, and 5 more elements. Let's just say there's like 2 elements that's the same. My partition algorithm works for that case too. If the element is the same as the pivot, it will put on the right sublist, not the left sublist. And there we go. This is a perfectly sorted array. I hope my demonstration, my code makes sense. I did not comment that much, but I did draw all this to explain how my code works, and I hope it makes good sense. And thank you for watching, Professor.